Hello everyone and welcome to my class. Let me share my screen first. Say yes in the chat if you can see my screen. If you can't, say no. So can everybody see my screen? Yes, very good. Okay. So now let's continue our topic of Euclidean geometry. But first, let's do a little review of what we learned last lecture. All right, so this is our schedule. After we review last lecture, we will be learning about the graphs of different equations. And the big idea to take away from this lesson is the equation of a circle, which we'll be working on this class and part of next class. All right, so first let's review the distance between 2 points A and B. All right, so how do we find the distance between 2 points A and B? Okay, so let's say we have A here and B here. Okay, we have B here. All right. And we're trying to find the distance between them, which is going to be this. Okay, how do we find the distance? What we need to do is we need to use the Pythagorean theorem to find the distance between these 2 points. Okay, so you see here, if A is x1 and y1, and B is x2, y2, then then this height of this right triangle here would be y2 minus y1. And similarly, the length of this right triangle here would be x2 minus x1. So that's how we obtain this formula right here. The distance of A to B is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And we obtain this formula from the Pythagorean theorem, which states that a squared plus b squared equals c squared, meaning that the square root of a squared plus b squared would equal to c. All right. So that is how we obtain our formula here. Are there any questions? Any questions on how we find the distance between 2 points? If there are no questions, I will continue. Okay, so all right, how about we do a little review about finding distance between 2 points. So I'm going to give you 2 points, -2 and 4. And so this is point A and point B, which is 3, 5. All right, find the distance. Find the distance of A to B. All right, find the distance of A to B. I'll give you a few moments to use your scratch paper or your notebook to figure out the distance between A and B. How are we going to do that? We need to use this formula right here. So make sure you memorize that. The distance formula. All right, do we have any answers? The square root of 26. Okay, square root of 26. Are there any other answers than the square root of 26? So no other answers than the square root of 26. All right, let's see if that is correct. So we need to use our formula. The square root of x2 minus x1. In this case, this is x2, y2, x1, y1. All right, so 3 plus 2 squared plus 5 minus 4 squared. Okay? So what we get here, what is that? That is going to be the square root of 25 plus 1, which equals the square root of 26, and it can't be simplified any further. So square root of 26 is the correct answer. Very good job. Okay, so are there any questions on this example? Any questions? If you have a question, say yes and ask the question. If you don't have any question, say no. So I'm guessing there are no questions about this topic. Okay. So let's continue. Midpoints. We're going to find midpoints. Midpoints are very important when we're doing many of these problems. All right, so let's let me draw the classic coordinate graph. Okay, that is not a straight line. Okay, so we're gonna have the same points A to B. All right, and this is the distance between them. And then in the middle of this segment AB, all right, let's make this segment. In the middle of the segment AB, we have M, which is the midpoint of AB. All right. So if you were to find the midpoint of AB, what you would need to do is you need to find the measure of AB and divide it by 2. All right. Okay. So, but what if we had, what were our previous points? We had A, -2, 4, and B. So find the coordinates of M. All right, find the coordinates of M. Now, how would we do this? We can't just take the measure of AB and divide that by 2. Right, that's the distance from N to B or M to A, all right? We can't do that. So if you were to find the coordinates of M, how would we do that? And we can do that using similar triangles. Okay, so how do we do this? Okay. Let's call this x1 and x2. Right. y1, y2, and this will just be y and x. Okay, so A would be x1, y1. B would be x2, y2. All right, and the midpoint would be xy. So using our similar triangles, our knowledge of similar triangles, how do we find the coordinates of M? All right, so we need to notice that triangle AMP is similar to ABQ. All right. Because the definition of a midpoint gives us two congruent segments, then AM and MB, based on that definition, would be so AM over AB would equal to 1/2, right? And we can also say the same for AP and AQ. All right. So, okay, since AM and MB are congruent, or AM over AB is 1/2, using the knowledge that AMP is similar to ABQ, then we can conclude that AP over over AQ is also 1/2. Now, what is AQ? AQ is x2 minus x1, right? So then what is AP? AP, basically, the x values of AP would be x minus x1. And since M is in the middle of AB, then that means that 1/2 also equals x minus x1 over 2. All right. Wait, no, that does not make sense. Hold on, I made errors. So this would actually be x2 minus x1. Yes, right, because AP is x minus x1, and then AQ is x squared minus x1. All right, so from this, we can conclude that x1 plus x2 over 2 would be the x value of M. Okay? Because we know that x minus x1 over x2 minus x1 is 1/2, using our knowledge of similar triangles. Now, the y value of M can also be obtained in the same way using similar triangles. Okay, so the y value would be y1 plus y2 over 2, right? So let's find an example. Okay, actually, no, we already had one. Okay, let's use this example. This was actually, yeah, this was our example from last time. So how do you find this? To find the coordinates of the midpoint of segment AB here, we need to add the x values together to find the x value of M, and then add the y values of A and B, and then divide by 2 to find the y coordinate of M. So let's do that. Okay, so -2 plus 3 over 2, and then 4 plus 5 over 2. Okay, so that's how we find the midpoint, the coordinates of the midpoint of AB. Okay, so that would simplify to 1/2 and 9 over 2. Okay, so does anybody have any questions about this one? Any questions? No questions? Okay. And of course, Steven has magically disappeared for some reason. I don't know where he went. Okay, so let's go over some review examples. All right. We used this examples last time, but we need to refresh on these ideas. So, number 1, show that ABC, triangle ABC, is a right triangle where A is -1, -3, B is 6, 1, and C is 2, -5. How do we do this? Does anybody have any ideas on how we prove that ABC is a right triangle? Very good. Very good. So basically what we need to do is we need to find the distances between A, B, and C and see if they are a Pythagorean triple, meaning that A squared plus B squared equals C squared. All right, so let's do that. So what is our Pythagorean theorem? A squared plus B squared equals C squared. I'm gonna put this up for reference. All right, so the distance between AB would equal, okay, what would it equal? It would be 6 plus 1 squared plus 1 plus 3 squared, okay? And then, what does that equal? That equals 49 plus 16 equals 64, 63. Okay, and what would the square root of 63? What would BC be? BC would equal, hold on, I made errors. 65 right here, 65, right? Okay, square root of 65, and then BC, what would that equal? It's the square root, okay? It would be 6 minus 2 squared, okay? Plus our y values, we have to subtract them too. So it'd be 1 plus 5 squared, which equals 16 plus 36. That equals the square root of 52. All right, and our final one is AC. Okay, AC. AC, we need to do 2 plus 1 squared plus -5 plus 3 squared. It's 9 plus 4. 9 plus 4, which equals 13. All right. Square root of 13. Now, if you square AB, square BC, and you square AC, then that is equal to AB squared. 13 plus 52 equals 65, which means that yes, this is a right triangle. So very good. This is a right triangle. Okay. So does everybody understand how we prove that ABC is a right triangle using the Pythagorean theorem? Are there any questions? Any questions? No questions? All right. I'll move on. Okay, so number 2, suppose that A is -1 and -3 and B is 6, 1 again. Okay. Now find the Pythagorean theorem. Find the equation of the perpendicular bisector of AB, right? How do we do that? So we did this last time, so I'll just walk you through it. So AB, we can kind of assume it's around here. Okay, AB looks like this. Okay, hold on. I need to redraw this coordinate plane. So AB around over here. Okay, approximation, or maybe not like that. Okay, a bit farther. B is a bit farther over here. Kind of like this, all right? The segment A, B. Seriously? Got kidding. All right. Apparently this does not want to work today. Okay, fine. This should be fine, hopefully. All right, so our perpendicular bisector is the bisector of AB, all right? Creates a right angle, okay? It's perpendicular, right? And the point where this perpendicular bisector intersects AB is the midpoint. The bisector. The bisector creates a midpoint, and midpoint creates two congruent segments, AM and MB. Okay. So since AM and MB are the same, then the equation of this perpendicular bisector, okay, we have point P on this bisector, which is X and Y, right? So we need to prove that AP and PB are the same. Okay, that's the equation of the perpendicular bisector. So we're going to get x plus 1 squared plus y plus 3 squared equals x minus 6 squared plus y minus 1 squared. We're going to expand. I'm going to save you the trouble up here. After expand and combine like terms, it's going to be 14x plus 8y equals 27. All right. So this would be the equation of the perpendicular bisector. Okay, so let's finally move on to new material. So we're gonna be sketching different equations. All right. I need you to be familiar with these equations. We don't need them right now exactly, but we will need them later on, right? When we start learning about domain and range and different functions. All right. So let's start. Okay. So when graphing different equations, all right, graphs of different equations. Let's start by sketching an easy one. Y equals 2x minus 1, all right? You've all learned slope-intercept form. All right, so this should be quite easy. Now, all we need to do, actually, slope-intercept form is very easy to graph. We don't even need to use a chart. Okay, you just need to know these, all right? What is this? We have -1 as our y-intercept, all right? It's over here somewhere. Okay, and then we have what? 2x. Okay, that's our slope. Go up by 2, go up by 1. Okay, like this. This would be our line, right? Very easy. Okay, so now let's look at some different graphs. Okay, let's look at some different graphs. Now let's look at some examples. These are very common graphs. Okay, x squared, x cubed, and the square root of x, right? So let's look at that. Okay. So first, let's sketch y equals x squared, right? There's a special method to graph these quadratics, but when we're new to this, we don't really use that method, right? It's much easier to see what this graph does if we use a chart, all right? We get -3, -2, 1, 1, okay? That should be enough. We have 9, 4, 1, 0, 1, all right. So you have points, right? Because y equals x squared, then if x is -3, then y would be x squared, meaning it's 9, all right? Now let's graph these points on this, okay? On the coordinate plane, see what they look like. All right, you see here that as y decreases, right, when x decreases, x goes from 0, -1, -2, y still increases very fast. And when x increases as well, it doesn't matter. Y still increases very fast because it's squaring. It doesn't matter if it's negative or positive. All right. So you can kind of see here. Oh, that's negative. Okay. Kind of see here what the graph looks like. Oh shoot, that kicked me. Okay, hold on. Let's not graph the first one. That's too troublesome. All right, so you can kind of see here the trend line. All right, kind of a U here. You get a nice U. Okay, this is called a parabola. All right, this is what you get when you graph a quadratic. All right, so make sure to remember the graph of this x squared. Whenever you see an x squared, this will be the graph of it. Okay. All right. And make sure you remember this for our functions unit, because we'll be using this a lot during when we're learning about functions. Okay. So let's see. You have now we have negative x cubed. All right, so let's see what that looks like. Okay. Let's create our chart. So -3, -2, -1, 0, 1, 2, 3. All right. So if you cube, to take the negative of the cube of all these, you get 27, 8, 1, 0, -1, negative, wait, -8, -27. You see, it kind of, it's a kind of like a squiggly line in this one, right? You plot the points, it kind of looks like this, right? Basically, this part of the parabola reflected downwards because in a parabola, it's x squared, right? No matter if it's negative or positive, you square, it's always positive, right? So it's always going up. It's in quadrants 1 and 2. However, if you take the cube of a negative number, then it's still going to be negative, right? Okay, so that is how we get this graph over here. So now let's look at our last function or graph that is very common, the square root of x. And this is called an exponential function. And we have learned this before. All right, so this should look pretty familiar. All right, I'm going to save you the trouble of trying to create a chart. An exponential function, as you can see, the x increases a lot. However, the y, not so much. Okay, Unlike like a parabola, the x increases a little bit, the y shoots up very fast. This time the x increases, the y stays, once it gets over here, it stays pretty constant. Right. Okay. So these are the graphs of three very common graphs. Okay. So now let's look at the main topic for today, the equation of a circle. But before we go on to that, are there any questions about what you just learned? Any questions? Any questions? If there are no questions, then we'll move on. Okay, so the equation of a circle. All right, so what do we know about circles? What do we need to graph a circle? All right, let's brainstorm a bit. What do we need? What is needed? What is needed to graph a circle? What is needed to graph a circle? All right, let's brainstorm this question. All right, what do we need to graph a circle? All right, I'm giving you a hint. There are two things we need to graph a circle. Just two things. All right. Now, if you wanted to graph a square, that would be a very different case, right? You need 4 points, right? But with a circle, because a circle, it's very special object, right? Very special. Okay. We only need two things to graph a circle. Okay. What are those two things we need to graph a circle? Are there any answers? Any answers? What are two things we need to graph a circle on a coordinate plane? What are two things we need? All right. Does anybody have answers? All right. Yes, very good, Sophia. The radius and the coordinates of the center. Okay, the radius and the center. Yes, exactly. That is what we need to graph a circle. So that is what's going to be an equation of a circle, right? And that's what's going to be in the equation of a circle. So let's create our coordinate graph here. Hold on. So we have let's see here. Let's draw our circle first. All right. Hold on. Let me make it look better. All right. So this is our circle, right? We have a circle. Okay. And we're going to have our center here, which will be HK. The center of this will be HK. Center is HK, all right? And we have a point on the outside. This point, P. It's on the circle, right? On the circle, which means it's okay. The distance, meaning the distance between the center and P is the radius, okay? It means on the circle, okay? So P would be X and Y. Excellent. This pen sucks. Gotta be kidding me. Seriously? Come on, come on. Gotta be king. All right, so P is x, y. All right. So how would we find the equation of a circle? How would we find this equation of a circle? Okay. So we just use the distance formula, right? This is why the distance formula is so important. Okay. Because the square root of x minus h squared and y minus k squared would equal the radius. Okay? Because that's distance between C and P, and therefore that would be the equation of a circle. However, we don't like square roots, alright? So let's square both sides. So basically what we get here is x minus h squared plus y minus k squared equals the radius squared. And that is the equation of a circle. Okay, that is the equation of a circle. Okay. Are there any questions? Any questions on this? Yes. Okay. No questions? Then we'll move on. So, graph the circle x minus 2 squared plus x plus 3 squared, which equals 16. How would we graph this? Now, I encourage you to graph this in your notes or graph this on your scratch piece of paper, but you don't need to do that. We can't do that in the chat. So I would like you to put the center, coordinates of the center, and the radius of the circle in chat, because those are the two things we need to graph the circle. So those are most important. All right, so please put the center and the radius in the chat once you figure it out. So does anybody know the radius or the center of this circle? All right. So what is the center and the radius? Okay. How would we find this? Okay, I'm gonna give you a few moments to answer. All right, I think we already have answers. Okay, center is 2, -3, and the radius is 4. Great job. Okay. Because what is our formula? X minus h squared plus y minus k squared equals r squared. So you have to square root 16 to get the radius, which is 4. Okay. X value of the center is 2 and -3. Now we can graph. Okay. 1, 2, 1, 2, 3. It's over here. Okay. So if we were to graph this, we would need a radius of 4, right? Radius of 4. Okay. Let's see here. Points 1, 2, 3, 4. So the circle would be tangent to these points. You can use these as an outline for our circle. I know, it looks very bad. Okay, so this is our rough draft of our circle. Okay, the center to -3. Okay, and the radius equals 4. Okay, so that is how we would graph our circle. Are there any questions on how we graphed this circle? Any questions? Okay. Where did Carney go? I don't know. Steven and Carney both died or something. Actually, that's a possibility. It is a pandemic after all. No, that's dark thought. Let's not think about that. Okay, so number 2. Find the center and the radius of the circle graphed by x squared plus y squared plus 4y minus 117 equals 0. All right. Find the center and the radius of the circle. How do we do this? How do we do this? I'll give you a few moments to do this. Okay. All right. So we have some answers. Okay. So the center is 0, -2, and blank. Agreed. Okay. Radius. I love it. How do we do this? What is the method you would get this to make the equation of a circle? What is our method we would use? Right? Who knows the method we can use? Turn this into the format of our equation. What do we use? Okay. What do we use here? So what we use is completing the square. Yes, completing the square. Very good, very good. We complete the square here. Okay, so we get x squared plus y squared plus 4y equals 117. Okay. Then you need to recognize that y plus 2 squared equals y squared plus 4y plus 4. So add 4 to both sides. All right. So you see here, the center would be 0, -2, okay? And then the radius would be 11. Are there any questions about this? Any questions? Yes, Edward, you've been going to my class for almost about a year, I think. I'm pretty sure. I hope you have learned some things. Oh, first thing I taught you were combinations and permutations. Combinations and permutation. Oh yes, combinations and permutation. Factorial, probability. Yes. Okay. Yes, I did teach a class about combinations and permutation. That was a while ago. All right, that was a while ago. Okay. So hopefully you've learned a lot of things during this year, Edward. Okay. So you better have. So, great job on completing this problem. And that is the last problem for today. So we will end a little bit early today. So thank you for listening, everyone, and I'll see you the next time. Okay. If you have any questions, and what the heck is bedmass? BEDMAS. What's that? Forgive me if I don't know what it is. And you feel like your classmate or order of operations. Wait, what? Bedmass. What is that B doing there? Isn't it supposed to be parentheses, exponents? What is B? What the heck is B? It's supposed to be pedmas. Oh, brackets. Oh. Well, same thing. Okay, so here's look at your classmates can't even do order of operations. Ah, yes, I do like P better. Pedmas sounds better, I guess. Yes, so without further ado, we will end this class, and people have been leaving already, so why not? I'll see you next time. Oh, and don't forget to subscribe to the YouTube channel. Because why not? It's awesome. You can learn new stuff. And hopefully you understand. Why wouldn't you?